Hey guys, in this video we'll be setting up a new mean stack server from scratch on AWS EC2, then deploying an example mean stack application to it that supports user registration and login functionality, so we can test that the server works as expected. A mean stack app is one that's made up of a front end built with Angular that connects to a backend API that's built with Node.js, Express, and MongoDB, which is what gives it its name. So within this tutorial, we're going to cover setting up the server and deploying, configuring, and testing the application. Now, the pieces of the application, the Angular front end and the Node.js backend, we won't be covering in detail as they are covered in separate blog posts, which I have linked to within this post if you're interested in seeing those. As usual, all of the steps that I'm going through in this video are covered in this blog post, which I'll link to in the video description. Now in this video we'll be going through these steps. So first we'll be creating the new server on AWS EC2 running Ubuntu, and we'll connect to the server via SSH. Then we'll set up the server to support running mean stack applications with the software required to do so, so Node.js, MongoDB and NGINX. We'll then deploy the backend API, the Node and MongoDB backend API to the server. We'll then build the front-end application on our local machine and deploy it via SSH to the server. Then we will configure NGINX to serve the API and front-end from the same port. So we'll be using the NGINX reverse proxy, so we can serve both the front-end and the API both from port 80, which we'll see when we get to that step. Finally, we'll test the mean stack app in a browser to see that everything works as expected. Okay, so first step is to create a new Ubuntu server on AWS EC2. So the first thing we'll do is log into the AWS console by following this link. Okay, so on the console page, if you don't already have an account, you can create a new one and follow the prompts, or if you do, you can sign in. I've already signed in previously, so this will log me straight into my account. Once you're logged in, go to the EC2 section and select to launch a new instance. Within the launch instance page, select free tier only to only display machine images that are eligible for the free tier, and filter the list to only display Ubuntu images, and then select the Ubuntu 1804 image. Click select. Select the T2 micro instance type, which is eligible for the free tier, and then select the Configure Security Group tab. On this tab, we want to be able to connect to our server via SSH, which is what we'll be using to connect via the command line, so we can configure the server. And the other port we want to be able to connect on is the HTTP port 80 in order to test our web application once we've set everything up. So once those are both in there, click Review and Launch. Confirm that all of our settings are correct and click Launch. This brings up the select an existing key pair or create a new key pair pop-up. So we'll be using an SSH private key pair to connect to the server via SSH. We'll choose to create a new key pair. We can name this anything we like. I'll just call it my AWS key, and then download this key. And then you can click Launch Instances. And then you can scroll down and click View Instances. And you can see that that instance state is pending, and that should be launched shortly. So we can go back here and see what our next step is. Okay, we want to connect via SSH. We are running on Windows, so we'll follow the steps for Windows. So we'll be connecting using PuTTY. So I'll open that link, which takes us to the AWS documentation to connect to Linux from Windows using the PuTTY client. So if we scroll down and go to this link and download PuTTY from the PuTTY download page, with the 64-bit installer for the version of Windows we're running. Once that's down, open and leave all the defaults selected. We don't need to view the README. Okay. That would have installed PuTTY Gen as well, which is what we need to use for converting our private key file into one that works on Windows. So if we open using the Windows S key, enter PuTTY, if we launch PuTTY Gen, and then load our private key file from our downloads directory into PuTTY Gen, click OK. And then we want to save the private key out. Click Save Private Key. We're not worried about putting a passphrase on it. And we'll save it using the same name. So enter my AWS key. Save. And we should see downloads. It doesn't show the extension, but if I change, so this is a fresh Windows virtual machine, which is why some of these settings haven't been changed yet. So let's show extensions for all file types. So my AWS key.ppk. So that's our converted private key that we'll be using to connect to via SSH using PuTTY. So our next step is to connect to our Linux instance. So we'll open up PuTTY itself. So again, Windows S for search and open up PuTTY. Enter the host name as Ubuntu and and then the public DNS for our instance. So if we go back to our instance page, we can see this is our public DNS name. Also, the instance state is running now, so our instance is up. Copy the instance name to the clipboard. Go back to PuTTY. Paste that in there. I'll save the details in here. And under SSH, click Auth and browse to our private key file. Click Open, and then selecting Open, clicking Yes that we trust this host, and now we are connected to our server via SSH. Just expand this window a little bit. Okay, moving on to the next step. So setting up the server with Node.js MongoDB and NGINX. So this is all the software required to run our mean stack application. I won't go into the details again of how to install each of these pieces, as I've posted a separate blog post covering the details of how each of those is installed. You can follow this link here to see details. In this post, all we need to do is run this curl command, which runs the script from that other blog post, which installs everything we need. So going back to PuTTY, pasting in that command, hitting enter, see that Node and npm are getting installed. MongoDB, PM2, which is a Node process manager for production servers. NGINX, which is our reverse proxy web server that we'll be using to access both our API and front end. and a firewall to add an extra layer of security at the server. Okay, now our server is set up to run mean-stack applications. Next, we'll deploy the Node.js and MongoDB backend API to the server. So we'll be cloning and the backend into the /opt/backend directory using the command sudo git clone and then the path to the Git repository, and then passing it the path to the folder that we want to clone it into. So entering that command. Next, cd into that directory and install and run npm install to install all of the node package dependencies. Okay, once that's done, we'll start the API calling pm2 start server.js, which starts the Node API under the pm2 process manager. Okay, our API is now running. It's actually running on port 4000, which isn't accessible publicly, as we've only got port 80 and 22 accessible publicly on this server. We'll be able to test it a bit later once we make the API accessible using NGINX as our reverse proxy server. So moving on to the next step, we'll build and deploy the Angular front-end app. First, we'll clone the Angular project into a folder in our local machine by calling git clone and then passing the repo URL. Now, because this is a new Windows virtual machine, the first thing I need to do is actually install Git. So going to download the Git CLI and running that. And all the default settings are fine to choose here. Okay, Git is now installed. I know that I'll also need to install Node.js in the next step, so I'll jump over and do that now. Again, all the default options are fine for this. Okay, now we've got Git and Node both installed. We can go through all of these steps. So first thing, let's clone our Angular project. So copy that command, and let's open up a command prompt. So Windows and the S key to search, type CMD, bring up a command prompt. Expand this window a little bit, and I'll just clone it into the downloads directory. So cding into the downloads directory, and I'll paste in that command there to clone the Angular project. Next step is to run npm install to install the node package dependencies of that Angular project. So cd into the Angular project directory and npm I, which is short for install. Yeah, that's all installed. Next, we'll make a couple of small modifications to the code because the front-end app by default is set up to run with a fake backend. So it doesn't need an API to run when you're first testing. We want it to run with our real backend API, so we'll make a couple of tweaks to the code to enable that. So first we'll open up the source app module.ts file, and then we'll be removing these 4 lines of code, or 2 comments and 2 lines of code to remove the fake backend from that. So going into downloads, source app module, we want to open that with, I'll just use Notepad to keep things simple. And removing that those two lines and those lines. Save that file, close, and we'll be configuring the path to the API. In the Webpack config, we want to set the path to the API to just /API. So going to the root project folder and editing Webpack config. The default path to the API is localhost 4000. As I mentioned before, the API is running on port 4000. And that's fine for if you're running on your local machine or if port 4000 is accessible publicly. But generally on a public server, it's either port 80 or 443. In this case, it'll be port 80, so we'll be just accessing it via /API, and we'll be using NGINX to pass that through, which we'll see in the next step. So just changing that to /API, saving, and closing. All right, next we'll build the Angular app with npm run build, which will build our app using Webpack. So if we run npm run build. Okay, that's finished building. And we can see that it's finished building by the existence of this dist directory. And this is our compiled application. Okay, the next step is deploying from, we're on Windows, so we'll be following these instructions. So the first step is we'll connect to the server via SSH, which we're already connected, and we'll create a new folder for our app running this command. So we'll be putting it into the /opt/frontend directory to match the /opt backend directory for the backend that's over there. So back onto the server and run that command. Next step, we'll be changing the folder to be owned by the Ubuntu user. Now this is to allow us to transfer our front-end files, what we'll be doing in this step. When we connect, we transfer using the Ubuntu user. So when we've created this folder, it's currently owned by the root user. So we run this command to change the owner to be the Ubuntu user, so it has access to transfer our compiled files into it. So on the server, if we run that command, and then next we'll be using the putty secure copy command to transfer our dist folder over to our server. So it'll be using the path, so the command is of the structure pscp is the command. You pass our private key file with the -i flag. -r is the recursive flag to pass an entire folder. And then we pass the path to our folder and /star to be all the contents of it. And then setting Ubuntu as the user at the domain name of our server, and then the path to the folder on the server that we're transferring to. So I will copy this and edit it in Notepad just to simplify things a little. So copy that. Let's open up Notepad. Paste, turn on word wrap, path to our key file, it's over here, let's access the full path, downloads this way. So I can copy it from up here. Just copy that. paste there. Then the path to our dist folder. Copy that here. And then we'll get the domain name for our server from the AWS console again. Copy that there. Paste. And then copy the entire command. And paste into the Windows command window. Hit enter. And we can see our files all transferred. If we go back onto the server and we list the contents of our front-end directory, we can see that our 4 files are there for our front-end, our Angular front-end. Okay, so that's worked. Let's see what's next. Okay, configuring NGINX. Okay, as I was saying, the front end and back end are 2 separate projects, and when you're running locally, it's fine to have them running on separate ports, but on a production server, we want them both served from port 80. So to do that, we're going to use NGINX to serve the front end files from the root path, and we're going to use the /API path to reverse proxy through to our API that's running on port 4000. The configuration for all this is in this server block, and there's details for what all of those pieces do just below here. But for now, we'll just set it up on the server. So first, we'll run this command to delete the default NGINX config that was created when we installed NGINX. So on the server, run that command. Then we'll recreate the file as an empty file using the nano text editor. So run that. So that's our blank config file. Let's paste our configuration into it. Wrong command window. Let's paste that in there. And Control X, Y, and enter to save. Next, we run this command to restart NGINX so it has all of the new config settings. Alright, that's all done. Now we're finally to testing our app. So let's test, and if we've followed everything correctly, it should all work. So opening a new tab, enter the domain of our server and hit enter. And there we have it. There's our application. Just to make sure it's all working, I'll register a user. Hit enter. Don't need to save that. And log in. Alright, looks like that's all worked. Okay, so that's how you set up a MeanStack server on AWS and deploy a custom MeanStack application to it. I hope you enjoyed the video. Thanks for watching, and if you'd like to see more, please subscribe to my channel below. Okay, cheers.